Okay, so to start multiplying two fractions together, it's really just one big fraction like this. So I'm going to rewrite it as 8 times 6 over 20 times 2k. Now, you have a couple of choices. If you want to, you could come on in and you can multiply straight across. So you could say that this is 48 over 40k. Now, you would have to simplify it further. You'd have to realize that you could take different numbers out of both 40 and 48. Maybe you first start by taking a multiple of 4 if you wanted to. If you take a multiple of 4 out of this, this is really the same as 4 times 10. 48 is the same as 4 times 12. So if you do that, what you can realize is that the 4's cancel out. So really what you're going to be left with now, if we rewrite this, is you're going to see 12 on the top and you have 10k on the bottom. Now, if you want to look at the 12 over 10, you can further simplify this. You can take a multiple of 2 out of here. So if you can realize that, taking a multiple of 2 out of this is going to actually leave you with 6 over 5k, which is the final answer. Now, if you have a hard time seeing that, let me just show you again. 12 is the same as 2 times 6. 10, so I can get rid of that. 10 is the same as 2 times 5. You can get rid of that. Now you can hopefully clearly see that you can cross off the 2's, and then you're going to be left with the 6 on the top and then the 5k on the bottom. Now, I personally don't like to multiply straight across and get these larger numbers. I like to try to simplify this thing up front. I'm just show you a different technique. You do not have to do this. There's lots of ways to approach it. I'm going to go ahead and multiply the 6 divided by 2 right now, or simplify that, I should say. So 2 goes into 2 once, 2 goes into 6 3 times. I'm going to see what I can maybe pull out of the 8 and the 20. So I know I could pull a factor of 2 because what I'm thinking is 8 is 2 times 4, 20 is 2 times 10. So if you kind of rewrite them like that, what you can notice is you can come in here and cross these 2's out. So if you do that, what's left on the top is going to be the 4 times 3, or your 12. And then on the bottom, you have your 10k, which is really the same thing we had over here. So now pull out a factor of 2 out of here. 2 goes into 12 6 times, 2 goes into 10 5 times, and we are left with the same answer. So approach it however you like. Lots of different ways to simplify this. Now here's another multiplication problem. So remember, first thing I like to do when we have this thing called binomials, again, which are the 2 pieces, is I do like to rewrite it. I will just combine it as one big fraction, but then I'm going to put parentheses around all of these so I don't screw it up. And I'm going to rewrite this so it's a little bit bigger. So over here I'm going to have n minus 2 times n plus 5. Those are 2 separate groups. And then I have 8. N minus 16 is one group over n plus 6. First thing I like to do is see if there's any matching groups, and there's not. They have to be identical, so you have to see exactly 8n minus 16 on the top and the bottom and cross it off, and you don't see any of that, so nothing to cross off. Second thing I do is I go to all of the binomials and I see if there's anything I can yank out of them. There's no common numbers in any of these 3, but this one I can. So let me just rewrite it first. I'm going to keep the n minus 2 and the n plus 5. There's nothing to simplify. But from this guy, we can pull out an 8. So I'm going to pull the 8 out. Don't have it disappear. 8 divided by 8 is just 1, so it just goes to n. 16 divided by 8 is the 2. Then I have n plus 6. Now, clearly, we can see that one of the groups can be canceled out, so I'm going to come on in here, and n minus 2 can go away. There's no other like group, so really this is my final answer. I have the n plus 5 on the top, I have the 8, and then I have the n plus 6 on the bottom. So in the spaces here, I actually have this. It shows that I have parentheses divided by something, and then parentheses again. So what I want you to type in here is the n plus 5. Don't type the parentheses, I already have them. This is called a monomial. It's a one-piecer, so that goes there by itself, not in parentheses. And then wrap it up with the n plus 6, and that is how you simplify. Do be cautious of the difference between this problem and the first one. Again, this one is very much chapter 9. Question 1 was more like chapter 6, where you could cross things off with exponents. So here when we have binomials or trinomials, only the like groups can be canceled out. which is what we saw, was the n minus 2 is the only thing in common. When there's no pluses or minuses in here, then you can just start crossing off, and it's a little bit different. Okay, here's another one. By the way, if you look at the answer key here on the bottom, you're going to see it. I'm going to get something in parentheses on the top divided by something singular. So really our goal for what we're going to want to type in is going to be something in parentheses divided by just a single value. Let's go ahead and do this. I am going to rewrite it again with parentheses as one long problem. So I'm going to do in parentheses here 6x plus 10. And then times, I'm going to drop that x symbol. I don't like this multiplication symbol. It looks like an x. We just put them right next to each other. X minus 4. Over here, I'm going to have 15x cubed plus 25x squared. And then I have a times 2 sitting out there. Again, when I first start, of these four groups, can any of them be naturally crossed off? And again, it has to be one on the top and one on the bottom. There's not, so I can't do anything. My next step is going to see if I can factor anything out. The 2's done. The x minus 4 is done. But these two here, I can actually factor something out. So let's rewrite it. This 6x plus 10, I can pull out a multiple of 2. So let me do that. I'm going to write the 2. Don't lose it. 6 divided by 2 is 3. 10 divided by 2 is 5. And then I'm going to write the x minus 4 again. This guy right here, I can actually yank out, it looks like here I'm missing one of my x's first of all, so let me fix how I rewrote it. You're going to notice here this says squared and I dropped it, so put the squared there. When I go to this though, I can pull out an x squared and an x and another x squared, so let's pull out an x squared at the most, and then I can also pull out a multiple of 5 because they both have that in common. So let's pull out the multiple of 5, and then also an x squared is the most. It's called the greatest common factor. 15 divided by 5 is 3. If I pull out an x squared, I'm left with a single x. 25 divided by 5 is 5, so it's plus 5. When I pull out that x squared, it's no longer there. And then don't forget I have this 2 floating out there. Now, a lot of the time in these problems, you're going to have something that naturally crosses off. So when you do this, if you notice nothing crosses off, double check your work. Clearly we can see here this group, the 3x plus 5 and 3x plus 5 are going to go away. So I can cross those off. And there is something else too, this 2 here. I can cross 2 divided by 2 off, so that goes away too. What I'm then left with is going to be x minus 4 on the top, and on the bottom is 5x squared. When you type it on Schoology, be careful. This is the caret key. If you're in a foreign language class, make sure your international keyboard is turned off. If it looks really cute when you type it like this on Schoology, it doesn't read it right. You must have the international keyboard off and use the caret key. Here's a problem on division. If you can do multiplication, you can do division. What division is just multiplication, but you change this to multiplication and you make this the reciprocal. So I'm going to rewrite it first. I'm going to put the 6 here, 6, and then I'm going to change the colors. K squared plus 7k plus 6. Put that in parentheses. You know, put the 6 in parentheses too, might help you so you don't mix anything up. Then I'm going to change the division to a multiplication symbol, and then I take the reciprocal of the second one here. So I'm going to flip that, becomes k plus 1 over 1. So now this looks just like a multiplication problem. Remember, multiplication, all we have to do, it's one big fraction, so I just do that. Let's see if we can naturally cross anything off. Nothing matches up right now. What can I factor? The 6 is good, the k plus 1 is good, the 1 is good. This trinomial can be factored into 2 groups, so let's do that. I'm going to rewrite the 6 here, and then I'll do the k plus 1. And then this can be factored, so I'm going to do 2 groups. Remember, k squared broken up twice would be k and k. I need multiples of 6 that will add to 7. It's going to be plus 6 plus 1. Now, this 1 sitting out here, you can rewrite it or not. It really doesn't make a difference. When you're trying to factor this here, by the way, folks, trying to think of it, look and see what's above. Odds are, and this isn't necessarily true, but odds are there's going to be something you can cross off. So when I saw this, I thought, I wonder if there's going to be a plus 1 I can cross off. So I tried 1 and 6, and it works. Let's go ahead and simplify this through crossing off k plus 1. And you're going to notice what I have here for your answer key. The format for this one is just one thing on the top and the parentheses on the bottom. So what you're going to type here on Schoology is going to be the 6 on the top. We don't put parentheses around that. And then I already have the parentheses typed, so it's just going to be k plus 6. Okay, another example of division. Again, it's just multiplication really, so let's go ahead and change the division to multiplication and then take the reciprocal of that. So I'm going to rewrite this problem using the parentheses. We're using v this time, so v minus 6 over 2v minus 12. I'm going to change it to times. I'm going to reciprocal or flip the second one, so it's v minus 4 over 4v squared. Again, multiplication is just one long problem or one big problem, so all I'm going to do here is come on in and make it look like one big problem. Again, look for anything that can naturally cross off. I have 4 groups here. None of these 4 groups match on top and bottom, so nothing I can do. Can I factor anything out? Yes, it looks like here I can't or can't. Here there's nothing to do, but here on this last one I can. So let me just rewrite the problem. On the top we have v minus 6 and v minus 4. On the bottom here I can pull a 2 out, so I'm going to yank the 2 out. That's going to leave me with v minus 6. And don't forget there's a 4v squared here. For crossing off, we do have something. We have our v minus 6's go away. Now, you're going to notice on the answer key here, the answer key I have, it looks like this. We have parentheses on the top and then nothing on the bottom. Clearly, it's v plus minus 4 on the top. On the bottom, bring together the 2 times the 4v squared. Well, 2 times 4. Don't add them. You don't see an addition sign between the 2 and the 4. So it's 2 times 4 is 8. And then v squared, we're going to use that caret key again to type it in. And that is the right answer. This right here. Now we're switching to subtraction and addition. Remember, whenever you add or subtract fractions, you need a common denominator. Multiplication and division, you don't. You just go straight across when it's multiplication. So on subtraction, we need a common denominator. Great, I love it. It's already done. So to do this one is really not that bad. I'm going to go and just say it equals. Well, the common denominator is just 6y. That stays the same. What I need to write here is this. I need to do 3x plus 4. I'm going to keep that in parentheses. And it's minus 4x plus 4. Now, be careful. Most common mistake here is you forget to distribute the negative to everything. This subtraction goes here and here. So I'm going to rewrite this problem. I'm going to put the 3x plus 4 here. And I'm going to drop the parentheses this time because when we add and subtract, we're trying to get like terms together. If you want to keep the parentheses, you could. But the negative in the 4x is negative 4x. The negative in the positive 4 is negative 4, all over 6y. If you add your like terms on this, what you're going to see, we have a 3x and a negative 4x because it owns a sign in front of it, so it's negative x. And plus 4 minus 4 is just 0, so there's nothing. And then this is over on the bottom, 6y. Again, on the Schoology here to type it in, it's just one thing. Over the other is what you're going to do for typing. This is an example of addition. Works very similar to subtraction. Problem with this one, the common denominators are not the same. So you need to make the bottoms look identical. The larger denominator here is this 4x squared. It's kind of the most involved one. Can I make this guy look like 4x squared? Sure. How do I make the x become a 4x squared? Well, I just come in and I multiply it by 4 times x. Well, if you do it to the bottom, you have to do it to the top. So when you rewrite this, what you're going to get is 4x times 1 is just 4x over 4x squared. And then we have this component here still, plus, I'm going to put this in parentheses, the x minus 2, because it's a group, over 4x squared. Thing that's nice about this, the denominators are the same, so when I rewrite it, I can actually start that already. So it's going to be something over 4x squared. And what I'm going to do is just evaluate this top. So I'm going to do 4x plus, if I wanted to distribute this positive, it's really just positive 1. There's really nothing to do, so you can just drop the parentheses. Or if you want to think about it, you know, a positive 1 times a x is a plus x. A positive 1 times a negative 2 is a negative 2. So it doesn't change. It just becomes this right here. Now simplify the top here. 4x plus x is 5x, and then we have minus 2. And that is a group on the top, so you want to be cautious of that, over 4x squared. You're going to be tempted to maybe forget these parentheses, and you're going to think, oh, I can cross these two, and the 2 and the 4 can simplify. You can't. This component here on the top is one group. It's a binomial, a 5x minus 2. You have to be able to have a group just like that on the bottom to cross off. You can't. And I will tell you, for our purposes, the adding and subtracting and our final answers, I'm not going to really have anything that can be crossed off at the end. When you get into Algebra 2x, sure, that's fair game. They absolutely could have problems like that. So when I type it in, again, look at the format. This top half is the parentheses, so type 5x minus 2 and divide it by 4x squared. Question 8 here is another addition. I need common denominators. The bottoms have to look identical. So this is a little bit more involved. You basically want, the easiest way to do this is to have them have the same components. So this is a binomial, this is a trinomial. What I would first do is put this in factored format so that it looks like these little binomials. So let me show you this. I'm going to rewrite it. The first is going to be 1 over b plus 5 in parentheses. And then that's plus, in the parentheses on the top, and put b plus 8. Now, this right here, folks, this trinomial can be factored, and they're going to be factorable. So your goal in adding and subtracting is to get the binomials, the two pieces on the bottom. So let's rewrite this trinomial as two binomials. So I'm going to do that. I'm going to get it set up. And the b squared gets set up, split up as the b and the b. Then I need multiples of 10, so either 10 and 1 or 5 and 2. That will get me 7. And look at this bottom. This has a 5. I'm guessing this might also. So odds are the combination here is going to be 5 times 2. So let's try it. Plus 5 plus 2. Does it work? Remember, just double checking. This term and this term needs to give you the middle. So this is 5b. That's 2b. That adds to 7b. So we do have the right combo. Now, because of adding, we need the bottoms to look identical. They almost are. The one thing I like is I do see that both of them have a b plus 5, so they both have that. Well, what does the other one need? This one has a b plus 2. Fine, let's give this guy a b plus 2. So I'm going to add a b plus 2 over here. If I do it to the bottom, I have to do it to the top. Now, my denominators are common, they're identical, and I can simplify. So I'm going to rewrite this problem. I'm going to put the b plus 2 on the top. And it says plus, in parentheses, b plus 8, all over the same denominator, so I'm just going to rewrite it as 1 of the b plus 2 and 1 of the b plus 5s because they're identical. Then I just need to go up here to the top and add my like terms. It's going to be b plus b is 2b. A 2 plus an 8 is going to give me the 10. So what you're going to have here, write it down here, is you're going to have 2b plus 10 as a group. And then on the bottom here, you're going to have a b plus 2 and a b plus 5. And then you would be good. I am okay at this point if we just keep this as our answer. Algebra 2x would have us go a little bit further on here. So I do want to show you one thing. For our intensive purposes, what I am testing is that you can do this right now. Okay, if we were in our brick and mortar classroom and not doing this online, I would push you a little bit further. But you're going to notice, just look at the answer key that I have set up. On here I have 1 blank divided by 2 blanks. So you're going to type this in over this and this. Let me just show you though quickly Algebra 2x. And again, if we were in the classroom, I'm going to push you a little bit more. We can simplify this top guy here. Let me just show you. I can actually pull out a 2 on this. So this would be 2 times b plus 5. And then on the bottom I have the b plus 2 and I have the b plus 5. Well, this is kind of like the multiplication and division when we were crossing stuff off. I told you for adding and subtracting we're not going to worry about that. These would cross off. So Algebra 2x would say, wait a second, this guy here is really the final answer. It can be further simplified. Again, for our test purposes, look at the answer key. You're going to see that I had 1 blank on the top and 2 on the bottom. I am not going to require you to have to further simplify your final answers when we are in addition or subtraction mode like we are here. By b and b. The last one we have here, we're going to do some subtraction this time, and again we need a common denominator. Clearly the bottoms are not the same. So can we make them the same? Well, just take a little bit of everything. So why don't we have all the bottoms have a v minus 7 and all the bottoms have a v plus 2? So what I'm visualizing is this, is I'm going to get a common denominator that is a little bit of the one and a little bit of the other. Fine, I'm going to have, they both have to have that piece. So this guy here is missing the v plus 2. This guy here is missing the v minus 7. Okay, we can fix that. I'm going to rewrite this so it's a little bit bigger. Let me just get it fresh here. V minus 7 minus 3 of the v plus 2. Now, if this, because this here is our common denominator, again, just a little bit of that one and this one together, I can add what's missing. This first one needs to have the v plus 2, so do it on the bottom and the top. I'm going to add it here. This guy here needs the v minus 7 to the bottom and the top. So now I have a common denominator. I'm just going to write the common denominator as our v minus 7 and a v plus 2. And then here I do have to go and distribute the 8. And here be careful, this is a negative 3, distribute the negative 3. 8 times v is 8v, 8 times 2 is 16. Negative 3 times v is negative 3. Negative 3 times negative 7 is plus 21. Now, just adding our like terms together at the top, we're going to have an 8v minus 3v is 5v. A 16 and 21 is going to give us 37. And then that is going to be over our v minus 7 and our v plus 2. Again, this top, the final answer is the group. You're not going to have to worry about simplification. This can't be simplified any further, but again, even if it could have, I would have just required this as your final answer. Hopefully this review was helpful. Please let me know if you have any questions on wrapping up Chapter 9 and understanding this material.